law of sine. Those of you paying attention, to stuff the teacher in the past, I've used this. I used it the other day with Robert. I did the law of sines right, but I did the law of cosines wrong. So we'll get to that in a couple of days. Yes, the law of sines allows you to do stuff that this is for non-right triangles. Now, it actually works with right triangles, but why bother? We already know how to do right triangles. Okay, so this allows you to do stuff for non-right triangles. So, for instance, if I had a triangle that looked like this, no matter what else in the front of a right triangle. If I have a triangle that looks like this, I have a triangle that looks like this. There, that's not right. If I have a triangle that looks like this.
I think it is.
All right, and I do this angle, and I do this side, and I do this angle, and I want I know this side is, and I want to find that side. We could do it if it was a right triangle. We can't do it if it's not a right triangle. So before I give you the law, so I'm going to go do it. I'm going to show you where it came from. Okay. This is where it came from. All right. So what they're doing here is just saying, listen, I can take any triangle I want and drop down a height. Does that make sense? We just did. And they say, okay, if you look at angle A, sine of A is H over C, H1 over C. Everybody okay with that? Then they said, well, we're going to solve that for H1. So H1 equals C sine of A. Everybody okay with that? Then they do the same thing with C. And they get H1 is A sine of C. So what do we know about these two things? They're equal. So they set them equal to each other. And then they said, well, if I have C sine of A is equal to A sine of C. If I divide both sides by C, I get sine of A equals A sine of C over C. Well, if I divide both sides by A, here these cancel, now here these cancel, and you end up with sine of A over A equals sine of C over C. And you can do the same thing for B. So that means we also have sine of B over B. So this is nice because does this work for only right triangles? It works for all triangles. So we don't have to use just use right triangles anymore. Any triangle you can drop down and height and do that out. So this works for all of them. So that's the actual law of sines. So you want to write down the law of sines. The law of sines says sine of A over A equals sine of B over B. Now that's 1. You can also, they're both also equal to sine of C over C. So basically what they're saying is if you take an angle and the side opposite, and you take another angle and the side opposite of that one, they always have to be equal to each other. But you have to take sine of the angle. You just put in your number angle and work. And I just put 42 down here and I put sine of 42. No, you have to have that. So let's look at some examples. Okay, we're going to example 1. Now what does that SAA mean? Let's try Shannon. Look at example 1. It says SAA. What does that mean? Think back to geometry. Okay. Side angle, angle. So what this means is if we have a triangle, now I'm just going to draw all my triangles like this. Okay? They're not going to look right, but if we have a triangle, and they give me, let's say, B, C, and they give me a side and two angles. But it's a side and then the next two angles. So they give me angle A is 46 degrees. And angle C is 63 degrees. So what side do they have to do to make this work? Why are they giving me the wrong side? Oh, and side C is 56. So this is side, angle, angle. You could have gotten this one too. Side, angle, angle. So side A or side C. Yeah. I just put it in whatever order I want to put it in. It doesn't have to be. All right, so now, well, what this says is if we're looking for a little angle. Do I know this angle? Yeah. So we never say angle side angle because isn't it the same thing? Because you don't know all three angles all the time. You have two of them. So what is this angle? Do not make me do it in my head.
71.
No, you were right. That's all. That's why I said don't make me do it in my head. I don't want to do it. Thank you. All right, 71. All right, so now if I want this side, that means I want side A. So sine of A, 46 degrees, over A equals sine of C, 63 degrees, over C, 56. All you guys get to do your favorite thing. What do you get to do now? Cross multiply. We get 56 sine of 46 equals A sine of 63. I haven't touched the calculator yet. What do I do now? Divide by sine of 63. So A is equal to 56 sine of 46 over the sine of 63. Everybody stick that in the calculator. Make sure you can do it. First of all, is it going to be bigger than or less than 56? Robert? Less, because this is 63 angle, this is a 46. A's got to be the small side. It's got to be that. Okay. What'd you get, Zach? 45.21. How many people got 45.21? That's right there. So now, I have this. This is 45.21. Well, but I want to solve the whole triangle. So what do I have to find yet? B. This is side B across from side A, angle B. So now I'm going to come back here. Okay. So I want to find B. Sine of 71 degrees over B equals, now, do I want to use A or do I want to use C? That? Why? It's not rounded. This side's rounded, we don't want to use that one. So we're going to use C again. Sine of 63 over 56. Well, after a while, you understand it's this times this divided by this. So B is 56 sine of 71 over sine of 63. And B equals 59.426. Round it for me, Derek. 59.43. And we solved the whole triangle. So I would like you guys to do on page 602, check point 2. Same turn? Yeah. Let's see. Zach, come on up, tell me how to do it. I didn't ask. Bring your calculator. So everyone be quiet and pay attention. Okay, you will.
So basically, B equals 117.5 because you take 180 minus 12.
Okay, so I got angle B. Everyone understands how I got that? That's fine.
And then you take the, I'm solve for C first, then you take the sine of 22.5 over C. And set it equal to the sine of 117.5 over 12.
Put down.
Then we cross multiply, and then that step down.
Okay. All right, let's see one more.
C is going to be 5.18.
That's a few steps, okay. Is that what everyone else got? Okay. Did anybody have trouble finding B? Good. Okay. So for your assignment today, basically that's all you're going to have to do. Now tomorrow we're going to get into slightly more difficult problems. You have to deal with the ambiguous statements. It's always fun. But for today, you're just going to do that. So for your entertainment and enjoyment,